Hello and welcome. NeoCon, in partnership with AEC Daily, would like to welcome you to the NeoCon 2022 virtual CEU presentation of Design It Healthy, Keep It Healthy, Strategies to Support Resilient, Healthy Interiors, presented by Dr. Black.
Thank you very much. I'm delighted to be here today and happy to have you join me as we talk about resiliency. By the end of the presentation today, I hope you'll be able to define resiliency, understand external stressors and internal stressors and how they relate to the built environment, describe how exterior conditions can affect the interior conditions of our buildings and our environments, and explore research-based strategies and case studies to help us gain knowledge of how to specify resilient, healthy materials and use resiliency practices. We'll talk about all of the resources that we have available to help us design healthy, build it healthy, and keep it healthy. For the agenda today, we'll divide it up into three parts. One, we'll address resiliency and kind of add that human component to what resiliency means. We'll talk about the exterior environment and how that can impact the environment. And then we will talk about, in the end, everything that we've learned, how to design it healthy and keep it healthy and operate it healthy as well. So part one addresses the resiliency particular issue. In the world of green building, you probably have heard the word resiliency. It's somewhat of a buzzword, but let's explore really why it is such a significant topic right now. Many of you are totally aware of climate change and the effects that we are seeing in our weatherization. We're seeing more and more weather perils, things like heat waves, hurricanes, wildfires. And last year alone, there were 20 separate weather climate disaster events with losses exceeding $1 billion each. These 20 events also resulted in over 700 deaths. So in the United States alone, more than 40% of Americans live in counties that have been hit by climate disasters. And more than 80% of all Americans have experienced a heat wave. And the cost of destruction continues to mount, and we've topped at over $100 billion in 2021. So 2021 was not an anomaly, and that's very important to remember. The U.S. has sustained 323 weather and climate disasters since 1980, where overall damages and costs reach or exceeded $1 billion. The total cost of these events have exceeded trillions of dollars, a very significant impact. So what is important? Who is impacted the most by these severe happenings? The most severe harms, unfortunately, from climate change are falling upon the disproportionately underserved communities, those who are least able to prepare for them and recover from them, or even withstand the economic impact. 40% of African American communities are likely to experience increases in mortality rates due to extreme temperatures. 34% are more likely to live in areas with increases in childhood asthma diagnosis, primarily due to particulate air pollution. So what does this mean when we talk about defining resilience? The design and construction industry issued a statement on resilience back in 2016 that established the definition as the ability to prepare and plan for, absorb, recover from, and more successfully adapt to adverse events. Primarily, this definition has been applied to the structure of the building, primarily on the outside. But as we go forward today in defining resilience, we're adding to that definition so that we can address it in a more holistic manner to make sure that it safeguards human health and well-being from both internal and external stressors. And I guess one way of saying this, in other words, is we need to consider what happens on the inside of building and how that impacts how we live, work, and play in them as well as the outside. So overall, a shift is occurring. This edition of understanding the overall holistic impact of our disasters and climate change are helping us shift in a way where we're thinking about resiliency from being reactive to proactive. It needs to be part of our everyday existence. We've seen in the past that if we don't approach the built environment in a holistic, integrated manner, that there can be a number of unintended consequences. Resiliency also should be considered on different time scales. The strategy that we use in short term, for example, maybe when a wildfire has started in a particular area, may be very different from those that we want to use in the long term when we're planning for a new community in a wildfire zone. Our more proactive strategies look at the long term, but a holistic approach to resiliency must include both short-term and long-term strategies. When we talk about resilience, we can be referring to a number of different levels. The past 2 years or so, we've certainly all been tested with our personal resilience when faced with the COVID issues. Moving outward, we can also refer to the resilience of a specific building, which is what this presentation will primarily focus on. But it's important to consider the larger context that building as an integral part of the resilient community, which is ultimately part of a resilient society. They all fit together. Each of these levels is connected, and we can't look at one without looking at the other. We need to move from personal resilience to an overall societal resilience. So there are different scales of resiliency. And thinking about the impact each of us can make, you might be familiar with the model of concentric circles. I'm sure you have. What you control, what you can influence, what you're concerned about, but maybe have no influence over. The idea is that we are more effective when we focus on the inner circle, what we can control. We hope we can empower you with knowledge today about how to build, design, keep buildings healthy. We'll focus on the strategies. We'll focus our strategies primarily on the areas that you can control. So how did we end up where we are today? Let's take a brief look back at building methods and codes. Prior to World War II, homes were built with materials that were often very durable. That was very important, but in many cases they were expensive and inefficient to construct. In the decades to follow, newer technologies and methods were discovered that were much cheaper and quicker to manufacture, and mass demand required that for economies of scale. But in 1989, we had a very significant hurricane, Hurricane Hugo, which was the costliest hurricane to date, impacting approximately 2 million people, killing over 60 people, and inflicting around $11 billion in damage. This particular hurricane revealed the shortcomings of existing building codes, which then further exemplified in 1992 when Hurricane Andrew became the most destructive hurricane to ever hit Florida. Issues with enforcement and inspection of buildings were realized, catalyzing investments in wind engineering, research, and ultimately modern building codes. Today, we're facing worsening weather events, and it reveals, again, the need for us to reconsider resiliency of our structures and a greater understanding of the human health and well-being that needs to be considered inside the environment as well. So how does sustainability fit into all of this? Well, let's consider the historical development of buildings from that perspective. Buildings were constructed durably, and their systems and components, unfortunately, were not very efficient. Energy, water efficiency were not integrated in some of the early build systems prior to the 1990s. Material sciences weren't as advanced, so products and systems just weren't efficient and not necessarily healthy. And then in the early 1990s, motivated primarily by high oil prices and the emerging energy crisis, The first steps were taken in the green building movement with a focus on environmental sustainability. And then about a decade after that, we started to realize the need to prioritize health and well-being in these green buildings. So the focus shifted or expanded to include not only green buildings, but to healthy buildings. Today, the worsening weather events that we're experiencing are impacting our building codes and highlighting the importance of resiliency. Now more than ever, we need to make sure that we seize the opportunity to holistically integrate both the green and healthy movement and consider the resiliency of the outside and the inside. So the stars are aligning for us, and we must continue to do this for resilient buildings. The two movements have happened somewhat in silos from each other, with some parts of the industry focused on hardening the physical durability of structures for resiliency, and other parts considering the health and well-being of the people inside. As it turns out, there's synergies between durable buildings and healthy buildings, and we'll look at strategies in more detail later in the presentation. But the good news is that many of these mitigation strategies have synergies across the various goals a project may have. The bottom line is that we're taking a holistic, integrative approach that has never been important or offered a bigger opportunity. So how can exterior environments impact the interior? Well, if you look at the outside, you know that we have a number of external stressors that are happening today, primarily weather-induced. These are high winds, storms, fire, extreme heat, snow, storm surges, all of those that many of you have experienced. But when we move to the inside, we also have a lot of internal stressors. And these internal stressors can contribute to a building's resiliency as well, and ultimately the health of the people inside the building. These internal stressors include chemicals, molds, particles in the air, temperature, humidity, dust, allergens, biological contamination that might occur. All of those impact the internal environment and the health of the people in there. So relative to understanding those particular stressors, what happens as a result of extreme weather? Broadly speaking, we know a lot happens, and depending on how durable the outside is, the inside can experience a range of impact. But even if the outside doesn't sustain damage, extreme weather can still impact the inside. For example, building materials can behave very differently, resulting in poor indoor air quality and more exposure for people inside, especially when sustained power outages occur and take our ability away to heat and cool the buildings. When building structures do fail, they can also cause additional problems. They can create waste that can be hazardous to our ecosystem, our air, our water systems, because they have to be disposed of. Those structure failures require new materials for repairs, replacement, which have an environmental cost, but also that provides an opportunity for us to seek more resilient alternatives. So now let's look more specifically at the impact of the three main weather perils that we face, starting with moisture. There are numerous types of weather disasters that can bring moisture into a structure. There can be strong storms like thunderstorms, there can be hurricanes, there can be flooding from different sources. But it doesn't necessarily take a weather disaster for moisture to have an impact on the inside of a building. Ideal relative humidity for an indoor environment is 40 to 60% relative humidity. Prolonged periods of high humidity, outdoor humidity, can come in and pose a threat on the indoor environment if the air inside is not properly conditioned. We're seeing more extreme events involving moisture, at least partially because of climate change. A warmer atmosphere, for example, can hold more water vapor, and an atmosphere with more water vapor can make more precipitation. So what is the effect of moisture on a building's interior? Many of you have seen it. You know that if you have high moisture in a building, you can get mold growth, and mold brings significant health issues to building occupants. Stachybotrys, which many of you heard, is the famous black mold, which primarily is associated with growth on cellulosic type materials, such as gypsum wallboard, papers, some insulation materials. That particular mold has been associated with certain respiratory diseases. But constant humidity, high humidity, moisture is necessary for the growth of that mold. Also, increased moisture can affect chemical outgassing. When the humidity rises, the ability of certain chemicals to migrate from a material into the air and into the settled dust increases. For example, a 10% increase in relative humidity can change formaldehyde emissions from a particular indoor product by 50%. It can easily go from 50 parts per billion to 100 parts per billion and exceed indoor air guidelines. So a particular formaldehyde has been a chemical that's been in focus a lot on the indoor environment, primarily because it is a carcinogen. It is one of the most frequently found VOCs in the indoor environment, and it comes from a number of sources. But one of the famous case studies was back when we had Hurricane Katrina. And after that particular hurricane, there were trailers that were manufactured for evacuees to live in and those whose homes have been damaged by the floods. Unfortunately, these homes resulted in high formaldehyde levels when people were put in there. And the issue of formaldehyde, really, we thought we were putting displaced homeowners in safe environments. But in reality, we found out that because of the high level of formaldehyde that was released from the primarily manufactured wood products in these trailers, was affected by the high moisture content of the air and ended up presenting levels that were unsafe for people. So as a result of that, there have been a number of things done, and limits have now been set for formaldehyde exposure from composite wood products. We now have the formaldehyde standards for composite wood products that was created in the state of California and then implemented by the US EPA into a national law. And even FEMA now has a construction specification for formaldehyde that it requires of all manufactured trailers to be used in disaster situations. Now, let's move next to extreme heat and understand the impacts of extreme heat. Extreme heat is very significant, and you're hearing a lot about it in the marketplace now. Things are getting hotter. And the extreme heat in general, what's the definition? Well, it's typically defined as weather that is much hotter than average for a particular time or place. And it varies depending on location, weather conditions, and even what the humidity and cloud cover might be. But it varies across geographies. For example, a May temperature of 92 degrees in Boston is extreme heat, but a May temperature in Phoenix would have to reach greater than probably 110 degrees to be considered extreme. But it is very significant. We're experiencing more. And people often hear about the heat index. What does that mean? Well, that's a measure of how hot it feels when the relative humidity is factored in, because the relative humidity can make that impact be perceived much differently. Extreme heat events in the United States are occurring on a frequent basis, and they're expected to become more common, more severe, and last longer as our climate begins to warm up and change in some areas of the country. Extreme heat causes more deaths than any weather-related hazard, more than hurricanes, tornadoes, and flooding. In addition, thousands of people who are exposed to extreme heat seek medical treatment each year. Each summer, we typically have almost 100,000 people seeking seeking medical care because of heat. Cities, in particular, are at an elevated risk from extreme temperature because cities and communities absorb more heat, and they can heat up faster because of all of the surroundings and the materials that are available in urban areas. This particular effect is called the urban heat island effect. Okay. So this particular slide just gives you a look at the expected temperatures May through July this year with specific areas of concern. And you can see that the expectation for extreme heat do vary significantly across the country. And this is what's projected, but things can always change based on weather patterns and activities. Now, how does extreme heat affect a building's interior? Okay, as humidity increases, higher temperatures are also associated with higher emissions from building products or off-gassing. Common sources of pollutants in our buildings are really from the interior furnishings and construction materials, things like paints and coatings, adhesives, cabinetry, wallboards, insulations, flooring materials. And some of the common pollutants of concern are volatile organic chemicals, things like toluene, formaldehyde, semi-volatile organic chemicals, some like fire retardants, phthalates. Higher temperature results in higher emissions. And I recall a particular study we did. We were looking at naphthalene that was coming from certain coating products used on some wood materials in a building. And we found that a 20% increase in naphthalene in flooring increased with every 10 degrees in temperature. Naphthalene is a carcinogen. That's certainly something we don't want to have increasing in our buildings as a result of heat. So, like many other environmental health issues, the impact of extreme heat are felt disproportionately across society. For example, we have a number of vulnerable populations, those that are challenged by poverty and homelessness, the elderly, the young, the pregnant, the socially isolated, those with pre-existing medical conditions, those that don't have rapid access to medical care. So it is a real problem, and it has impacts on some of our unequally associated communities, the African American, Latino, Asian, First Nation communities. We have hotspots across the United States. So low-income communities overall are often underserved by green spaces, for example, that can mitigate urban heat, and by civic opportunities such as cooling facilities that we just don't have those available. So they will be disproportionately affected. Now, let's turn to fire, which is the third significant weather peril. Wildfires are growing, and I think you know that. You hear a lot about wildfires, but we also have a lot of other residential fires. They remain a significant health hazard. Residential fires in the United States, we have many top causes of those, and they are of considerable concern because we use so many synthetic products in our homes today that when these products catch fire, they burn very rapidly because of the fuel, petroleum fuel, basically, that's provided, to the point where we now have what we call flashover. Typically, in a residential home today, you have generally 2 to 4 minutes to get out of that home before you have flashover, which means basically that you cannot exist in that environment. Years ago, when we used more natural products like cottons, etc., flashover time was closer to 30 minutes. So our new way of doing things has created more of a residential fire hazard for us. Wildfires in particular also are growing, and over the past 30 years, the average of more than 5 million acres of wildlands in the United States have burned annually. This is a lot, and climate change factors are intensifying this threat and the scale of the wildfires and the damage being done. So fire overall is a chemical reaction. I'm sure you all know this. It's a product of fuel, oxygen, and heat. Those are the three things we need. If unimpeded, the chemical reaction will continue until one of these three depletes itself. Okay, it's a simple but very catastrophic happening. If you look at the science behind wildfires, fire behavior is really a result of site-specific conditions. Fuel, for example, the greater the fuel load, the greater potential. Density, fuel height, moisture content all determine the behavior of burn. Weather, dry and hot summers mixed with strong winds can ignite and spread fire rapidly. The effect of periodic droughts dry out vegetation and create large areas of kindling that can burn easily. Topography, fire across the path takes the easiest ignition. As fire transitions upslope, it propagates embers and preheats fuels in a path, allowing it to travel faster. So wildfires spread in basically three different ways. They spread by direct flame contact, and that's when the flames come in contact with additional fuel. They can spread by additional heat, where there's enough heat that can transfer from a material and burn. And then it can spread by embers, which are small pieces of burning and glowing fuel that can be lofted and spread distances through the air primarily or along the ground and ignite additional fuel. Of all these methods, embers probably pose the greatest threat. Up to 90% of homes that burn down in a fire were ignited, typically by an ember. Embers can travel 30 to 100 feet, and they've even been observed traveling miles downwind from a wildland fire. The areas of concern during wildfires are those where human development is occurring near a wildland area. These areas are known as the wildland urban interface, or WUI, as we often say it. The WUI in the United States expanded significantly from 1990 to 2010 in both the number of new houses and land area, making it the fastest growing land use type in the continental United States. Okay, now, what is the effect of fire on the building interior? Let's talk a little bit about that. Fire obviously presents a significant risk to the interior of a building. The fire itself is introducing pollutants, the products of combustion, basically, a lot of oxides, a lot of carbon monoxide, a lot of hydrogen cyanide. But the indoor structure and products inside that catch fire can lead to the release of a lot of additional chemicals. For example, during one of our studies where we were looking at the flammability of residential upholstered furniture, we found that over 500 different VOCs were released during the burn of furniture. These included not only flame retardants, but also chemicals such as benzene, which is a class 1 carcinogen. And we found benzene levels in that burn greater than the occupational level that's allowed in the United States. Cross-contamination can also occur, and all of these pollutants that we generate during the fires can end up in our ecosystem, ultimately our water supply, for example. So when we talk about wildfires in particular, many come from not only our secondary exposure source, which is the indoor environment and all of those chemicals related to the materials and the furnishings, but also the primary exposure, which is the wildfire itself. Okay, so we have a mixture of those pollutants that are coming together. And those particular mixtures consist of a lot of chemicals, a lot of oxides, but also a lot of particulate matter. And this particulate matter is called PM10, PM 2.5, which are very fine particles that can travel into your lungs and cause pretty significant health issues. PM10 are the larger particles. PM 2.5, there's smaller particles that can penetrate lower into your lung system, even to the point where it can cross over the boundaries and get into your bloodstream. So you hear a lot about particulate matter being in the smoke of wildfires and being a very significant health concern. So now that we've talked about the perils, let's talk about how can we design it healthy and keep it healthy. It's our turn now to understand the impact the outside can have on the inside can have overall on health, and how we can do this right. So how can we actually influence resiliency for health? So we have a lot of opportunities, and we want to prioritize. We have construction practices, we have material selection, we have operations, we have all of those things that can help us do this correctly and end up with a healthy environment. When we talk about material selection, what are the keys? Well, you want some key attributes of materials that you select to put into your indoor environments. You want to make sure that these materials are chemically safe, that they don't contain toxic substances that can be a problem. You want them to be durable. You want them to perform their function. And you also want to make sure that they're not susceptible to moisture or climate issues, particularly with consideration of your geographical location. Okay. One of the materials that's important in the indoor environment is also furniture selection. Furniture is extremely important because most home fires that result in death have either been deaths have occurred either in the living room or the bedroom, primarily the areas where you have the largest amount of upholstered furniture. So when you're selecting furniture appropriately, you need to make sure that it also is chemically safe. Nowadays, people would like to have furniture without flame retardants, and that's possible because you can control fire through the use of fire barrier materials. You want to make sure that you have the fire safety covered, preferably without the use of toxic flame retardants. You also want to make sure that that furniture is durable. So we want to make sure we optimize these particular attributes and not just eliminate one for the other. So when we look at our specific strategies on how to future-proof our environments for the different extreme weather scenarios we've discussed, another concern is moisture, and we talked about the impact of moisture. Selecting and there are key things that are available to make sure that we control moisture and that we keep it in safe and comfortable operating ranges. We want to select and install appropriate heating, ventilation, air conditioning systems, or HVAC systems, to meet the needs of the location's climate. There are new HVAC systems coming on board. We have heat recovery, low carbon heat, new passive systems, all of these things that are being designed to optimize the needed conditions, but also the energy needs. Okay, we need to do that carefully. We need to select our building materials to make sure we have harder surfaces, less porous surfaces that can absorb moisture, grow mold. We want to avoid certain products that have cellulose-based insulation that are more prone to moisture absorption and mold growth. And we want to make sure that within the building, we consider the places that the moisture can come in contact with the materials and create a problem. The wall systems, the flooring systems, the insulations. We want to decrease the fluffiness of those. We want to decrease the cellulosic content, those sorts of things. And when we have casework, cabinetry, we want to make sure that we're choosing composite wood products that now meet the new national formaldehyde standard, that have lower formaldehyde content and less formaldehyde that's available to outgas with higher humidity. And one thing to keep in mind, people often want to know, well, how do I find a product that does that's mold resistant or moisture resistant? Well, there is an ASTM test. It's called ASTM D3273. And this particular test will show you whether a product or not is resistant to moisture. So I encourage you to look for materials and products that have been tested to that particular standard and shown to have minimal or maximum resistance to moisture, basically. Now, let's talk about the extreme heat issue, because that also, in addition to moisture, is very important. And building materials and engineering becomes very significant at this point. We want to make sure that we have low emitting furniture and materials overall, that we've got efficient HVAC systems that regulate the indoor temperatures, hopefully keeping energy demand and costs low while they minimize the environmental impact. And many of you are aware of the equipment that carries Energy Star or the Consortium for Energy Efficiency marks that indicate that they've been verified for low energy use. And lighting is very important from a heat perspective. Inefficient lighting can add to a building's heat load. So we want to switch to LED lighting, use strategies that help us dim, or have sensors so that the lights come on and off when needed. We want to use overall sensors in our buildings today. There are many great sensors on the marketplace for temperature, occupancy, lighting, carbon dioxide that help us optimize that indoor space to keep heat loads off and operate only during activity and when needed. And there's also the opportunity for using light-colored and reflective surfaces, cool roofs that absorb less heat by reflecting more sunlight, for example. We also have an opportunity to have cool walls that use exterior wall surfaces that stay cool by reflecting sunlight and emitting heat. We have cool pavements that are being developed that are light-colored and reflective and have coatings on them that reflect the heat. So a lot of those new technologies are evolving in the marketplace and available to you. And then we have what we call the green infrastructure, right? We can have green roofs, a green or a living roof, which is partially covered by vegetation. We can have green walls and vertical landscape with plants that grow in vertical systems along interior, exterior walls. All of this sort of green infrastructure also provides us a buffer from heat. So a lot of great technology that's developing. It's out there, it's available, and it's just important to learn about it, go and start specifying and using it. Now let's talk about wildfires a little bit more from the heat perspective, since they are a very significant increasing threat across the U.S. overall. So combating wildfires requires a combination of land management practices, land development, and building practices. So here's some strategies that are very common to apply. You want to have a zone around your home or your building, which are roughly 0 to 5 feet. That's called the near building zone. But that can protect your building. And in that zone, you want to install hard surfaces. You want to limit vegetation. You want to use fire barriers for outdoor furniture so it's not susceptible to catching fire from embers and things like that. Remember, embers ignite up to 90% of the homes that burn down in a wildfire. So we have the near zone that we can work with. We also have a next zone where we're talking about trees and shrubs that should be well spaced in groupings and well maintained. And then you can have a external zone 30 to 100 feet out where you have trees and brush spacing and proper management of all that so that you don't have dead trees and shrubs or have any sort of material that is right for fire. So when we talk about wildfires, we want to talk also not only about carefully designing these spaces, but also we want to move to the outside of the homes as well and talk about hardening the building envelope. It's extremely important to do that. So when we move to hardening of the building envelope, moving from the inside to the outdoors, we want to make sure that we use non-combustible materials. We want to make sure we use Class A roof covering systems. We want to make sure we use multi-pane windows with tempered glass. And very important to make sure the walls and the windows, the vents are covered with metal screens so that they can block embers from entering in. And we want to consider the materials on the inside of the home and their impact on the fuel load also as we consider the fuel load. And researchers over the years have compared flashover times for two rooms. One which had natural materials, and again, a lot of cottons and things like that, and the other which had more of the synthetic materials. And in these simulations, the flashover time, and this is a showing you what's happening during that simulation. In 4 different simulations, flashover time for the synthetic room ranged from 3 to 4 minutes roughly, whereas flashover time for the natural room ranged from 29 to 30 minutes. And you can see that very, very dark toxic smoke that started to come out of the synthetic room, which would be very, very hard to exist in. And then ultimately the whole room engages in a flammable fire situation. So we want to make sure that as we are hardening the outside and protecting from the wildfire entry, that we have done the things that we need to do on the interior to manage the fire if it does get to that particular state. And it's important to know that when there is a wildfire in the area, it's best to be prepared with tools. What can you do to help address the issues associated with wildfire? Well, I think I talked earlier about the pollutants that originate from the wildfires and the particulate matter being of genuine concern of the wildfire smoke that enters into homes. One of the best things one can do today is to use a supplemental air cleaner to help, and these are usually air cleaners that have HEPA filters in them that help scrub out the small particulate matter. There's also an accessibility of a do-it-yourself box fan air cleaner, as demonstrated here, that can be more accessible. Sometimes in wildfire situations, air cleaners, the supply of air cleaners is not sufficient. And also there are many folks that cannot afford to buy a $200 or $300 or $400 air cleaner. So there is the possibility of actually building a do-it-yourself air cleaner using a very simple box fan and a filter that you can buy from a home retail type store, putting that together and operating that. And the research studies have shown that this particular air cleaner can be effective in removing some particulate matter from the air. So I think in summary, what would be good at this point is really to talk about kind of our overall best practices. We've talked about a lot of different things through the presentations, but how do we design it healthy? No matter what the specific weather hazard might be, what are the best practices? Well, we should consider the overall emissions of a product and how it will behave in a real world situation. Okay, we should consider the geographic location when specifying materials. A product that's right for a hot, humid Miami may not be right for a low humidity, hot Phoenix type situation. So we have to consider the material selection more holistically. Just like the resilience of a home and withstanding weather, we select the materials. We don't want to put high wind rated shingles on a roof deck that's not fastened well. Along the same lines, it doesn't make sense to select low VOC insulation, then cover the walls with a high VOC paint. We need to optimize all of those things and think holistically. In a hurricane prone region, for example, it's better to build out of steel than wood, but reinforcing a building with steel and cement might make it more resilient, but it also might increase the carbon footprint. So you really have to consider the entire life cycle of the building. and make decisions based on priorities and needs. It's also very important to look for third-party certifications or test methods to qualify materials. There are a lot of those in the marketplace now, programs such as Green Guard that verifies materials to be low emitting. There are numerous ASTM standards and test methods that allow you to assess products relative to their durability and function, as well as mold resistant. And all I can say on that is when you're looking for third-party certifications, make sure you consider how those certifications are done. Many test methods today are using what they call standard conditions. So a material may be certified or verified for standard conditions, say 50% relative humidity, 75 degrees C. But if you're going to be in a hot, humid environment where it's 100 degrees and 80% humidity, you may want to make sure that material has been evaluated for those extreme conditions. So, continuing on our overall best practices, once we choose the materials and do our design right, how do we keep it healthy? And we have some good practices for doing that. We want to make sure that we use and maintain our HVACs properly. We want to use the highest efficient filter that we can. We want to change the filters when they're dirty. We want to use vent hoods in our homes over our ranges when they are available. We want to optimize humidity levels. We want to use dehumidifiers in high humidity environments. We want to open the windows and let the outdoor air in where appropriate. And there are certain parts of the country where we can do that. We want to make sure that we have ongoing seasonal maintenance on our HVAC. We want to make sure we eliminate any sources of moisture or condensation. We have any water leaks or anything like that, we want to get them fixed quickly. So, and if we're in areas where we have vegetation, we want to make sure that we remove dead vegetation debris. Make sure that we keep things like that away from our homes and our structures. So what's the big picture of all of this? Well, remember the opportunity we have is to design resilient spaces for both the outside and the indoor. And in order to do so, we need to take a holistic approach to avoiding unintentional consequences. And when we think about resiliency, we need to protect both the buildings and the people. And with more knowledge and more resources, we can find resilient and healthy solutions. So design seeks to optimize and harmonize the use of a space. All of these things become important factors. So we've talked about a lot of different things today and touched on a lot of different topics. Chemical Insights Research Institute has a lot of great material online. Various tools for you to read, to apply in your practices every day. So I encourage you to go there and look for those. We have a CEU course on specifying residential upholstered furniture to safeguard human health. We have a guidance document on managing fire and chemical exposure from furniture. We have application notes on how to do that, on how to consider both health and safety. We have a guidance document on how to build a do-it-yourself filtration device for cleaning particulate matter out of the air during wildfire events. And we have fact sheets on understanding wildfires and things like that. So I encourage you to go to the site. You can find those materials and feel free to contact us at any time with any additional questions you might have. And with that, I think I'm going to open it up for questions.
Thank you so much, Dr. Black. Again, such a wonderfully insightful and informative presentation. We now have some questions. I'm wondering if you'd like to turn your camera back on and join our audience. Thank you. Our first question, actually, before we get started, just a reminder to the audience that if you do have any questions, please feel free to post them in the questions box, and Dr. Black will get to them as quickly as possible today. So our first question of the day is, what are some of the worst chemicals we should be worried about off-gassing during extreme conditions, heat, humidity, and fires?
Yeah. Well, as many of you know, there are a lot of chemicals in our products today. I think there are around 140,000 chemicals that we use to manufacture the products that we use on an everyday basis. And unfortunately, we only know the health impact of about less than 5% of those. So caution is extremely important. But, you know, the chemicals that we're concerned most about today are those that fall into the toxic range. And those are chemicals called carcinogens. And you heard me talk about formaldehyde a good bit. Formaldehyde is a carcinogen, and that's one of the chemicals that's associated with a lot of products and commonly found. There are additional carcinogens like naphthalene, benzene. So carcinogens, but also there are two other classes of chemicals that are really important today. One are the reproductive toxins, and these are the toxins that we believe are affecting the reproductive systems, both of females and males. An example of that is a common chemical called toluene, which is a frequently found almost always in buildings, and that's a common industrial solvent. And then we have chemicals that we call the forever chemicals. And these are the chemicals that we're finding out that don't degrade easily, that if they get into our body systems, they stay there for a long time. If they get into our ecosystem, they also stay there for a long time. These are chemicals like phthalates, flame retardants. You heard me speak about those, and all of those chemicals can be associated with fires and byproducts of fires, byproducts of wildfires, and they also are also used in the manufacture of the products that we use today. So those are some examples.
And so what are the potential trade-offs of specifying low-emitting materials?
Well, there's a great trade-off because the programs out there now that verify low-emitting materials have reduced the emission capability of these materials generally from 80 to 90%. And in many cases, manufacturers who kind of went through that learning process and reducing the chemicals emissions of their products ended up replacing some of the more hazardous chemicals with chemicals that were more benign as an alternative. So there's a great upside to making sure that you select these materials that have been verified by the programs out there to be low in chemicals and free of toxic chemicals.
Great information. Thank you. What strategies can we recommend to clients who can't afford to upgrade their HVAC systems?
Yeah, well, that is a significant issue, and HVAC systems, one of the best things that we can do is to put a high quality filter on there. And the high quality filters today are the filters that have a pleated surface that many of you have probably seen. We generally recommend on new homes today that HVAC systems be designed to handle a MERV 13 filter. But if if an existing system can't handle a MERV 13 filter, we encourage you to see if it will take a MERV 11 filter or even a MERV 8 filter. To explore your system and just make sure you're using the highest MERV rating that your system will allow you. And the other is to operate your HVAC system as frequently as you can so that the air is constantly circulating in your home. That will help keep the air moving, help keep the pollution load down, and be beneficial. The only other addition I would like to add to that is to make sure that you maintain your HVAC system. Make sure you're not getting an overload of moisture in it, that the system is operating ineffectively so that moisture is condensing in your system. That would be a very bad scenario because that you put moisture on top of dirty filters, then you're going to get mold growth, which could then get circulated in your air. So just keep a watch on it and make sure that's not happening as well.
Great tips. Thank you for that. What type of interior spaces are particularly important to consider?
Well, the spaces interior that probably had the most impact on the indoor environment and the pollution that can result from those are typically the ones you look around. What are my big surface areas? It's flooring, wall coverings, basically, insulation materials that go into the walls and the ceiling system. And then last but not least are all of your wood products, because just about all wood that we use today in our kitchen cabinetry, shelving in our closets, etc., is typically wood composite materials, which are made with low formaldehyde resins, and in some cases even some of that resin has been replaced with non-formaldehyde resin. So those are the key products to really focus on.
Great. And how does resilience tie to social equity?
Resilience is extremely important to social equity because, you know, as I showed overall, we have to build toward a resilient community, and that means that resilience means that everyone is protected and has the same opportunity. And we've shown where many of the underserved communities are disproportionately affected by the extreme weather situations, whether it's heat, wildfires, and things like that that are occurring, and just lack of basic interior facilities, such as a lot of homes that don't have HVAC systems and things like that. So in order for us to be a resilient society, we have to contribute and bring everyone up to some standard of acceptability.
And how have you seen the design community starting to create more resilient spaces?
Well, you know, the design community has always been focused on having sustainable, healthy environments. You know, for decades, we've been focused on that. And the thing I like about the design community is that they always have open minds. They're always educating themselves. They're keeping up with the latest advances and trying to employ those in the marketplace. And in many cases, they may be ahead of the marketplace. And so I often see the design community kind of as market drivers, because they can see the opportunity for making changes for, in this case, more resilient, healthy environments, and they can specify the things that we need to do that and kind of drive the market to make sure that they are accessible.
And on a personal note, what products would you never introduce into your home?
Oh, wow, that's a tough question. And you know, I think when you're talking about your own home, you know, the more it becomes difficult to answer that sort of question, because, you know, everything that we use are made from chemicals. So we can't do away with them. We have to understand them. We have to use them intelligently. And to me, one of the more difficult products in a home are what I call porous materials. And these are the porous sort of textiles, and they may be on wall systems, they may be on floor systems, they may be in insulations. These sorts of porous materials that are absorptive, meaning they can absorb formaldehyde, they can absorb moisture, they can absorb anything that you get into the air. And so my approach overall is to minimize the use of these porous type of materials and go more for hard surfacing.
Wonderful. And with that, we have reached the end of our day today. And so I would like to extend a warm thank you to Dr. Black for presenting today and joining us. And I'd also like to thank all of the learners who have taken the time out of their day to attend this webinar. Just as a reminder, you can watch this session online anytime until July 15th via the NeoCon Hub, and this session will be available by the end of this week. We hope that you enjoyed the presentation and have a wonderful rest of your day.
Thank you.